Hello everyone, welcome to the new episode of AI for Healthcare Expert course. Today we will talk about how machine learning models trained from data, from patient data or from data from EHR. So how this magic happens, but actually it's not magic, it's just mathematics. Last time we very briefly talked that this is a minimization of error of prediction based on retrospective data. Now we will be able to see how it happens step by step and some potential caveats and things that we need always take into account when we train model or validate existing model in our hospital or in our research, for example. So as we talked last time, so AI model, like classical machine learning model, is something that multiplies some weights or coefficients on some features, on some parameters. It can be anything relevant to the field that we want to predict. In real machine learning models, it's usually dozens of parameters, but in our case, it will be just few of them. So, for example, we want to predict does patient have pneumonia or not. Stop. Yeah. Does patient have pneumonia or not? And we have temperature and amount of white body cells. So based on this information, we need to we want to develop model that will say the risk, the probability that this specific patient has pneumonia. So let's restart to make it more clear. So that's how it works. We have model that takes into account only two parameters, like temperature and amount of white body cells, and it has some for example, only 10 examples, 10 real patients. So we have one patient without pneumonia, this one, this, green patients without pneumonia, and red with pneumonia. And goal of our model to draw the line. So basically this is to fit coefficients in the way when most of the patients with pneumonia will be on the red background, and without pneumonia, so green, will be on the green background. So we see that model decided that this is the best way how to draw this line, because it's only one red patient detected like mistakenly and one green. So this is almost fine, and this is actually really important. So good model will never show you 100% accuracy, because very likely it will just remember the training dataset. It will perform poorly on new data. We will talk about this later. At the moment, we need to understand that that's how model works. We leave the same model, so it's still a formula that just takes into account some coefficient, multiply it on temperature plus parameter responsible for white body cells, multiply it on some another weight. And based on this, we get a score. We leave the same model, but we add more patients. So we train it not on 10 patients, but on 40 and 70. We see that it's now on 100. So this line changes after we add more data. So we added more data. Model knows better now which types of patients can be, and it changes these coefficients in a way that it will predict condition for all 100 patients, even if, for example, there will be more mistakes than it was initially, but still overall accuracy will be better. So now like it's 83%, and this is actually not bad. So we add more patients, so it will be. So we see that it changes a little bit based on new data. And also we can notice that in the beginning it changes significantly, and then with each additional 30 patients, this coefficient changes less and less, so it's almost always on the same line. And we can assume that when it will be like 600 patients, it will be preliminary the same line, so coefficients will differ not significantly. It means that our model on our training dataset works pretty well. So there are a lot of different ways how to train model on existing data, so how to make it more efficiently, how to make it more stable, how to avoid overfitting, how to improve generalization. So these things are relevant to like AI specialists, data engineers. It doesn't matter in this lecture. What we need to know that there are multiple options how to make this process more efficient. But mathematical core stayed the same. So we need to draw a line that will separate healthy and ill patient as more accurately as possible. So with less false positive and false negative results. We will also about metrics, we will talk about next episode, and we talked it already previously. What is important? We had the same model, but more data made it more stable, more accurate, so more reliable pattern. And this is the key of understanding about AI. In most of the cases, model pretty simple. We don't talk about large language models like Claude or ChatGPT, so they are really super complicated. But again, difference in, for example, computer vision model, some machine learning, that predictive things, time series data based on training data that model is trained. So that's the key. And this is pretty interesting. Next lecture will be about problems in labeling of data, because there are a lot of them. But some spoiler is that labels are usually done by humans, and with all the consequences that we have. So it can be errors in AHR system, it can be different definition that changes, it can be something that people just didn't add. Sometimes it can be disagreement regarding is it this diagnosis or another one. It can be bias regarding how we treat different types of population. And this is something that also data engineers need to take into account when they work with their respective data. So this is important to know where label come from. So we will have special short episode specifically about this problem. Okay, assume we have perfect labels. We tested them. We surely know that they correct. And what next? Then we need to take new patient and put it into the model. So what does it mean? Put into the model. We have temperature of new patient that was not previously in trained dataset. We take parameters for white blood cells and we put it into this formula. We calculate some risk, and risk will be 26% for this patient. Like that was calculation based on weights that were calculated based on all these 300 patients previously. And currently it matches the fact that indeed patient didn't have pneumonia, and model said that there is no pneumonia for this patient based on parameters that we know. And we do it now for every other patient that previously was not seen to the model. And we can check them one by one. So for example, for this one, patient had pneumonia and model said that it's 68 chance of pneumonia, and we said that everything that above 50%, that it means that we interpret it as pneumonia. So then it's pneumonia. And we can check on all 200 new patients, and we see that some of them were classified correctly and some of them not. What is obvious and what is good, because it means that there was no leakage of some test data, so it means that indeed model didn't see this patient, and it always will be some mistakes in AI models, as it always exists mistakes in some analysis, any other diagnosis regarding any treatment that we have. So what we need to remember is that machine learning means like recognizing all the pattern to generalize knowledge for new patient, not remembering the training data set, because it doesn't have sense, because we always will use model on new patients. So we need to learn pattern. Takeaway: model machine learning, any AI model, including large language models, including computer vision, like all machine learning models, they train not from like medicine, not from study books or something, not from rules like A more than B, but from training examples, from history, from retrospective data, usually from huge data sets, from thousands, sometimes millions of patients. For example, recently it was paper regarding classification of ECG data. So it was trained based on 12 millions of different ECG. So that's really huge amount of data, and we can assume that model can generalize patterns quite well to classify new types of ECG or new patients or new X-ray scans, etc., to provide meaningful decision support. What is important to take into account the quality of the data. About quality we'll talk next time, and how it works on new patients. So we always must to validate and test model on data that was not seen from by the model. And we need, what does it mean? That it should be data from another hospital or from another timeline. So we train on data from 10 years ago or 5 years ago, and we validate it prospectively. So we measure data now, for example, or we train data in Germany, and we validated on patients from France. So we need to understand how all the metrics stay stable and how meaningful decision support will be on another population. So that's what we do with AI, and that's how AI trains and how we can be sure that it works. Next time we will talk about metrics, and in one of the next lectures it will be very important about problems with data and how to mitigate them. Subscribe, share, like, ask questions. Really appreciate your feedback.